Hey, Katie. All right, I'm doing the next one. I am going to say this one is. Oy, oy, oy. This is the problem that was about a turntable that turns at 45 revolutions per minute. And then the question, we had two questions. We had what's the angular velocity? And then secondly, we had the question, what's the period? So let's think about what that means, 45 RPM. And omega W is equal to the change in the angle over change in time. Well, we know if it's 45 meters per minute, that the change in time, at least in the first get-go, is 1 minute. We're going to change that because we've got to really put that in seconds. And we got to figure out what the change in angle is at that point. Well, if it went 45 revolutions, each revolution it went an angle of 2 pi radians. And it did 45 of those. I'm going to write this differently. I'm going to say that the change in the angle, every time it does a revolution, the change in the angle is 2 pi. And so if it does 45 revolutions, the change in the angle is 90 pi. So that's great. Let's go back to this with omega. So omega equals delta theta over delta t. How far did the angle change? We already said that. It was 90 pi. And we said that it took a minute to do that. Well, that's not really in the spirit of the units that we're working in, because we really want to do it in radians per second, blah, blah. So to go from radians per minute to radians per second, we're going to have to divide by 60. And that's going to give us 1.5 pi. I'm going to go ahead and write it, radians. We don't need to write it really. Per second. And that's what omega is. 1.5 pi radians per second. So we answered question A, and I'll go ahead and highlight that. That's A. Then the second question is, what's the period? Well, the period is a little different. That's how long does it take to complete a cycle. And we have the angular velocity. We need to know how long it has to go through that angular velocity to go through a cycle, and a cycle is 2 pi. That's when it gets back to where it started. It started there. How long does it take to get back to there? And so really we know that this is omega is 1.5 times t equals 2 pi. And if you do the math, you get t equals 4/3 pi, or what did I think that the pi? Oh yeah, that has a pi in it. So it's really, sorry about that. It's really 4/3, or we could call that 1.3 repeating seconds. I prefer the 4/3, but that's me. All right, Katie, that's that question. I think at this point we're down to just, oh no, we got three more questions. I'm going to answer another question, and then I'm going to do another batch for you. I'm going to do the question that had to do with spinning around the Earth and the difference in speed at the top of the tower versus at the bottom of the tower. It's really not, again, not really that hard a problem. Hopefully, as you process all this crud, it'll seem not that bad to you. And again, contact me if you need more clarification. All right. Whatever the number of this problem was, it was Earth. The equator, I'm going to draw it this way this time. We did it. The equator and the top of the tower, and it's a 300-meter high tower. And the question was, how much faster is a point at the top of the tower traveling versus at the bottom. And you should recognize here that what we're really talking about is, you know, the Earth revolving, it's spinning around. At the top of the tower, it's traveling this distance as it spins around. At the bottom of the tower, it's only traveling this distance. And it's doing both of those things, each of those things in the course of one day. So it's really a question of what's the difference in the distance. But let's think about this. We have a velocity equals distance over time. And the velocity at the top of the tower is going to be whatever. I'm going to do the velocity at the bottom first. Velocity at the bottom is going to be, it's d equals 2 pi r. And it's a question of what r is. So velocity at the bottom is going to be 2 times pi times 6. The question said it was 6,400 kilometers. That's 6,400, but I got to add 3 more zeros to turn that into meters. And the time is 1 day till we turn that into seconds. The velocity at the top, well, I'll go ahead and do that here, is going to be equal to the distance at the top over the time. Time's going to stay the same. The distance is going to change. The distance is going to be 2 pi times 6,400. The radius is 300 more, obviously, because we have that extra 300 meters there. That is also over 1 day. The question is, how much more is one than the other? So I'm going to write it like this: V top minus V bottom. That's the question we're trying to answer. And that's going to be equal to 2 pi times 6,400 300 minus 2 pi times 6,400. Both of those things are over 1 day, so I'm going to write it all as being over 1 day. And I've got a common factor of 2 pi that I'm going to leave in there. And then really what I'm going to end up with is that the difference of those two things is 2 pi 64, whatever, 6,400,300 minus that is equal to 300. And that's divided by 1 day. And I think you can see where we're headed from here. That's going to be, that difference is going to be 2 pi times 300 over 1 day times, I want to turn that into seconds, so that's 24 hours, 60 minutes, 60 seconds, and then you got to do that math, but that's your answer. So, and the answer becomes pretty small. When we did it before, I think we figured, roughly speaking, that's about 1 out of 45 meters per second or something, so it's a small number. All right, Katie, that's that with that. I've got 2 more questions to do for you, which I'll do in a minute. I hope you're doing all right. Talk to you later. Bye.